Hey everybody, welcome back to my tech tips. We're actually going to do more of a machine spotlight to kind of show the benefits of each of our 4 different machines here. The first machine I am going to be going over is the Equator, which we actually sell as a CMM master from Verisurf because we actually error map the machine. So we go through and we actually do a cubic volumetric mapping process utilizing 24 parameter calculations to error map significantly improve accuracy over the standard comparator based Equator, because these are actually just built to be a comparator for a machine. You take a measurements from a actual standard CMM and then you use that information and you just compare to it. So we actually error map these machines, and these are actually accurate within 5/10, and it's almost can be used as like a standard CMM. So what I'm going to do now before I say anything else is I'm going to get this going so this can run in the background while we talk. So first thing I'm going to do is I'm going to do an alignment. So I'm going to go in here and run the alignment. I do a single point alignment on this one just because I know where this machine, I know this part's squared up on the axis on X, and I program this part so it matches. As long as your X and your Y match, you can just do single point alignments, and then everything else is automated. So I'm just going to go over here and take my first point. You always want your first point to be in a position that you can take relatively close and it's easy visually to pick it, because this is going to call this point 0, 0, 0 on X, Y, and Z. So we'll go here. So that's going to take that. I'm going to go ahead and press OK. And it's going to go and it's going to run through its automated routine doing the alignment. And then from here, I'll run the automated program and then we'll talk a little bit more about the Equator. So it's just going to take 3 shots across the top, a couple shots across the front. And we can have this all in the same plan or in separate plans. I actually have the alignment separate from the program that runs all the measurements just for demo purposes, to show that we can have them separated, and we can also just do a, let's say we want to just throw this part in there real quick and it hits up against the datums, and then we measure the datums in the program. We don't actually have to worry about running this auto line. We can run it ahead of time, and then we can just take measurements on parts. It doesn't have to run the auto line each time, because if we're going to do a datum reference frame system, we don't need to do this alignment. We're going to just use our datums that we're going to measure. So this is done now. It's going to go to a safe point. So it's going to go there, and then what I'm going to do is I'm going to run my measurement program. I'm going to go ahead and get this started. Okay. So this is going to just take off, and it's going to run through all the measurements. It's going to take the datums first. But I wanted to kind of talk about the equipment a little bit. So the great thing about this is that it's pretty affordable compared to a standard CMM. It's a little bit smaller on the size, but for small parts that you're going to be running multiples of, it works great. And let's go through the size. I got a couple different sizes that we sell. So what we sell is, it's considered a 300 millimeter size, which is, this is a 300. There's a 300 and there is a 500, and there's a XL of each. On the XL, you don't gain any measurement volume, but what it does is it builds up an extra 150 millimeters on the bottom side of it for fixtures and stuff. Because if we start adding fixtures and stuff to hold tools, we're going to lose measurement volume. So they offer that. The 300 size is basically it's 11.8 by 11.8 inches, and then about 5.9 inches on the Z. The 500 size gives you 19.7 by 19.7 by 9.8 on the Z. The 300 is, on the weight, it's only about 55 pounds. And the 500 is about 150 pounds. So, like I said, I can lift this one by myself pretty easily. all it takes is a 110 outlet. So this is pretty easily to put it out on the shop floor and just plug it into the wall. It does not require air. These things are pretty sturdy. The accuracy and the speed, the accuracy is about the same on each different device, but your movement speed is a little bit quicker on the 500 just because it's a little bit more sturdy with the size of it. The scan rate on the 300 series is 1,000 points a second, where on the 500 series it's actually 2,000 points a second. So there is a little bit of a difference there. Like I said, both of them do not require air. The 500 is a little bit heavier, but still it's not too bad. You can still put it on top of most workbenches you guys have. The scanning accuracy, like I said, 5/10. It's not quite the accuracy of a CMM, but it's a little bit tighter than your standard arm. And the biggest benefit is that it's hands-free. So you don't have nobody that has to run it. We went through and did a test, and it's about, I think we were about 7 or 8 minutes total runtime. We'll see when this video ends. But we did a test on the arm, and the arm was about 3.5 minutes. So you can see it's about 50% or 100%, I guess, longer to run it on here, but it's hands-free. And once you get it set up, like I said, you can just be slamming parts in there, and you can have multiple of these set up. So if you guys have any questions, or you want to see a demo of it live on maybe a different type of part, you can always reach out, and I could set something up for you. And we can always just set up the camera and set up a remote session so you can be looking at the computer and the camera at the same time. Other than that, that's really everything I got to show you. This thing has a few measurements left, so we'll let this finish and then we can just pull up the report. Also on this, compared to the standard CMM, this is doing the scanning. So this is a little bit quicker than a standard CMM, which has to take points because you are losing a ramp up and a ramp down each time you take a point. So we're getting rid of one ramp up and one ramp down on doing the scan method. I think I just take a couple shots across these. I basically measured all the same features on each device, and I created the same report on each device. So basically at the end of this 4-part series, you'll see that I created one program and ran it across 4 different devices just from adding paths. Basically, I created a program that was a manual program for the arm and the tracker, and I just added paths for the CMM and for the PH20 setup we have. Of course, they're a little bit different because I did the scans on the equator, and I just did standard points on the PH20. You can see right here, it's giving us live numbers as we're doing our scans. We're just taking points right here for an intersect. And then that's done. So I can go in here and I can pull up the report, show report, and we got every feature we need for this part measured for the print tolerances, and everything's to GD&T. Everything's using the datum reference frame because we measured the datums. And then we took screenshots of the holes. Right here you can see there's screenshots for all the holes, true positions and hole sizes, and then we did some screenshots for the surfaces. So like I said, you guys have any other questions, feel free to reach out. I am going to go through and do another video for each of the other devices so you can kind of see the ease and the benefit of each device. Like I said, on the CMMs, the biggest benefit is the lack of personnel. You don't need somebody to sit there and run it. Somebody can be doing something else while it runs. And then again, on the equator, it's a little bit quicker with the scanning compared to the standard CMM. My next video will be on the CMM. But I hope you guys liked the video. Feel free to reach out if you have any other questions or comments. Have a good one.